Hello there, welcome to Omeed Private High School online class. In this class, I'm going to explain some remaining topics of 11th grade physics, and today's topic is potential energy. Potential energy is the energy due to height of object. Okay, so it depends on height. If height is more, potential energy will be more. If height is less, potential energy will be less. Okay, let me show you the formula also. This is the formula, and this diagram shows as the potential energy. You see, this object with mass m located at some height from ground level. At this height it is located, so it has some potential energy according to this level. Okay, so we can say that if height is more, potential energy will be more. If height is less, potential energy will be less. Height increase, potential energy increase. Height decrease, potential energy decrease. Okay, now let's see the formula. Potential energy, EP means potential energy equal to mass of the object into gravitational acceleration of Earth into height of object from some reference level. So potential energy will be equal to m times g times height. M you know mass, g you know gravitational acceleration of the Earth, h you know height of object from ground or some other reference level. Okay. So let's solve a few examples to make it more clear. Example number 1, calculate the potential energy of the kite. Okay, here kite is given with mass 200 gram. 200 gram is it's equal to 0.2 kilogram. Okay. Height from ground also given as 30 meters. So here we need to calculate potential energy. Potential energy is equal to m times g times height h, and mass is given as 0.2 kilogram into g you know 10 Newton per kg times height, here it is 30 meter. Okay, now kilogram, you see kilogram cancel, the remaining terms will be 0.2 times 10 will be 2 Newton, here we have Newton, times 30 meter, and finally it becomes 2 times 3 6 and becomes finally 60 Newton times meter joule. So potential energy is equal to 60 joule. Okay, you see here one path is given like this and one height is given like this. Now let's see one important note about this. You see, this note says that potential energy does not depend on path followed. It depends only on initial and final values of height. Okay? So it does not depend on the path followed. Example number 2. Calculate the potential energy change. Okay, here we need to calculate delta PA. Delta PA, changes in potential energy. You see here, initially height was 10, now height is 4. If height changes, potential energy also changes. Here we are going to calculate changes in potential energy. Okay, unit delta means change, right? So from here, delta T E is equal to final potential energy minus initial potential energy. Okay, final is energy here. Initial means energy of the object at this height. Okay, so from here m times g times h2. Okay, h2. Why? Because final energy is energy of object at this height minus m times g times h1. Why h1? Because initially object was here at this height, so initial energy will be due to this height. Okay, from here mass unit is 3 kilogram. 3 kilogram times g unit 10 Newton per kg times height 2 is 4 meter minus m unit doesn't change, it is again 3 kilogram times g is 10 Newton per kg times initial height was 10 meter. From here this part becomes how much? Kilogram cancel. 3 times 10 30 times 4 120 joules minus this part will be kilogram cancel. 3 times 10 30 times 10 300 joules, and finally change in potential energy will be 180 joules. And it's minus. This minus shows that if height decreases, then potential energy will decrease. So changes in potential energy is 180. This minus shows the decrease in potential energy.